What if I told you that the United States military has weapons that can travel from Washington, D.C. to Beijing in 30 minutes, lasers that never miss their target, and robots that make battlefield decisions faster than any human commander? These aren't concepts from a distant future. They're operational today, hidden in classified facilities and deployed on secret missions around the globe. The age of science fiction warfare has arrived, and it's honestly more incredible than anything Hollywood ever imagined. Today we're revealing 10 game-changing technologies that are quietly revolutionizing how America projects power across the planet. Hypersonic weapons. The United States Army's Dark Eagle hypersonic weapon travels at over 3,800 miles per hour, so fast it could fly from New York to Los Angeles in just 40 minutes. This isn't just about speed, it's about totally redefining the concept of unstoppable force on the modern battlefield. Hypersonic weapons like the Long-Range Hypersonic Weapon System represent a quantum leap beyond traditional missiles. While conventional ballistic missiles follow predictable arcs that defense systems can intercept, hypersonic weapons maneuver unpredictably at speeds exceeding Mach 5, making them virtually impossible to stop. The Dark Eagle system uses a common hypersonic glide body that separates from its booster at high altitude and glides to its target at hypersonic speeds. What makes these weapons truly revolutionary is their strategic impact. Traditional intercontinental ballistic missiles take 30 minutes to reach their targets, giving enemies time to respond. Hypersonic weapons compress that timeline to mere minutes, creating a new category of warfare where speed equals survival. The Army plans to deploy these weapons in 8 missile batteries, with each missile capable of striking targets over 1,725 miles away. The December 2024 successful test of the Dark Eagle marked a crucial milestone, proving the weapon system's viability for operational deployment. Unlike nuclear weapons that serve primarily as deterrents, hypersonic weapons provide conventional strike capabilities that can be used in actual conflicts without crossing nuclear thresholds. This technology doesn't just change tactics, it fundamentally alters the strategic balance of power, giving the United States the ability to strike any target globally within an hour, while remaining virtually invulnerable to current defense systems. Directed energy weapons. Imagine a weapon that travels at the speed of light, never runs out of ammunition, and can precisely disable targets without collateral damage. Directed energy weapons make this science fiction concept reality, using concentrated electromagnetic energy instead of traditional projectiles to neutralize threats. The United States military deployed its first operational directed energy weapon aboard the USS Ponce in 2014, marking the beginning of a new era in warfare. These systems use high-energy lasers and high-powered microwaves to damage, disable, or destroy enemy equipment and personnel. What makes them revolutionary is their speed. Electromagnetic energy travels at light speed, which is about 100,000 times faster than hypersonic weapons. Current directed energy systems excel at countering drones, rockets, artillery, and mortars, providing cost-effective defense against swarm attacks. A single laser shot costs mere dollars compared to traditional interceptor missiles that cost hundreds of thousands. The Pentagon's roadmap envisions these weapons evolving to counter increasingly sophisticated threats, including anti-ship cruise missiles and aircraft by 2030. Beyond 2030, directed energy weapons will tackle strategic missions like defending against ballistic missiles and hypersonic weapons. Their speed-of-light engagement capability makes them ideal for countering maneuverable threats that traditional defensive missiles cannot intercept effectively. The technology's precision offers another advantage: the ability to scale effects from non-lethal disabling to complete destruction. This flexibility allows commanders to respond proportionally to threats while minimizing unintended consequences. As these systems mature, they promise to revolutionize both offensive and defensive operations, providing unlimited ammunition as long as power is available and reshaping how military forces protect themselves and project power. Autonomous combat vehicles. The United States Army's Robotic Combat Vehicle program represents the dawn of unmanned ground warfare, where machines fight alongside soldiers or independently in environments too dangerous for human operators. These aren't remote-controlled toys. They're sophisticated combat platforms capable of autonomous decision-making in dynamic battlefield conditions. The RCV program encompasses 3 variants designed for different mission profiles: The RCV Light serves as a nimble reconnaissance platform equipped with advanced sensors and lightweight weaponry, capable of deploying drones to extend surveillance range significantly. The RCV Medium bridges mobility and firepower with medium-caliber cannons optimized for infantry support, while the RCV Heavy features robust armor and heavy weaponry including anti-tank missiles and 30mm autocannons for high-intensity combat. What sets these vehicles apart is their integration of artificial intelligence and machine learning, enabling autonomous navigation and adaptation to dynamic combat scenarios. They can perform tasks ranging from reconnaissance and logistics support to direct combat roles without human intervention. The Defense Innovation Unit's ground vehicle. Autonomous Pathways project is developing software that fuses data from multiple sensors, allowing these vehicles to operate in diverse and challenging military environments. However, the program faces significant challenges. Development costs have escalated dramatically, and the vehicle's size and expense make them vulnerable to cheap drone attacks that have proven devastatingly effective in Ukraine. The Army is reassessing requirements to create more cost-effective, survivable platforms. Despite these challenges, autonomous combat vehicles represent the future of ground warfare, promising to reduce human casualties while extending military capabilities into previously inaccessible or extremely dangerous operational environments. Advanced cyber warfare capabilities. The United States Cyber Command operates the world's most sophisticated digital army, capable of infiltrating enemy networks, disrupting critical infrastructure, and conducting offensive operations in cyberspace that can, cripple entire nations without firing a single conventional shot. The United States has developed the most advanced cyber warfare capabilities globally, with Cyber Command centralizing command of cyberspace operations and synchronizing the defense of military networks. The command operates 133 cyber mission force teams, with 41 from the Army, 40 from the Navy, 39 from the Air Force, and 13 from the Marine Corps. These teams conduct both offensive and defensive cyberspace operations worldwide, targeting everything from enemy command and control systems to weapons platforms that, honestly, require computers to operate. What makes U.S. cyber capabilities revolutionary is their integration across all domains of warfare. Army Cyber Command delivers offensive cyberspace effects and electromagnetic warfare capabilities against global adversaries, while specialized units like the 780th Military Intelligence Brigade provide teams for national and combatant command offensive operations. The 11th Cyber Battalion deploys expeditionary cyberspace and electromagnetic warfare teams to augment tactical units with offensive cyber, information operations, and electronic warfare capabilities. Recent developments include advanced cyber threat detection capabilities being evaluated through partnerships between Army Cyber Command and DARPA. These systems can identify and neutralize sophisticated cyber attacks in real time, providing, unprecedented protection for military networks and systems. The true strategic advantage of cyber warfare lies in its deniability and precision. Cyber operations can disable enemy capabilities without traditional military signatures, making attribution difficult while achieving strategic objectives that would otherwise require conventional military force. Next-generation stealth aircraft. The United States Air Force's F-47 sixth-generation fighter represents the ultimate evolution of stealth technology, combining invisibility, artificial intelligence, and drone command capabilities in a single platform that, honestly, redefines air superiority for the next century. The F-47, developed under the Next Generation Air Dominance program, incorporates stealth technologies that surpass both the F-22 and F-35. This sixth-generation fighter features a potentially tailless flying wing design that further reduces radar signature while providing superior speed and maneuverability compared to current platforms. The aircraft's stealth capabilities enable it to penetrate advanced threat airspace that would challenge even existing stealth fighters. What truly sets the F-47 apart is its integration with artificial intelligence and autonomous systems. The aircraft is designed from the ground up to operate alongside drone wingmen through the Collaborative Combat Aircraft program, allowing a single pilot to command and coordinate multiple autonomous platforms simultaneously. This human-machine teaming capability multiplies the aircraft's effectiveness exponentially. The Navy's Parallel F/AXX program promises similar revolutionary capabilities for carrier operations, with 25% greater range than the F-35C and advanced AI integration that transitions from man-in-the-loop to man-on-the-loop operations. This extended range of over 1,700 miles, combined with refueling capabilities, provides, basically, indefinite operational reach. Both programs represent a fundamental shift in air combat philosophy. Rather than single-platform superiority, these aircraft serve as command nodes for integrated air combat systems that blend manned and unmanned capabilities, creating air power effects that no adversary can match with conventional fighters. Soldier Augmentation Systems. The United States Army's Integrated Visual Augmentation System transforms ordinary soldiers into superhuman warriors with heads-up displays that provide real-time battlefield intelligence, night vision, and augmented reality capabilities that fundamentally change how ground combat is conducted. IVAS, based on Microsoft HoloLens technology, represents a $22 billion investment in soldier enhancement. This mixed reality system combines day and night fighting goggles with heads-up displays that integrate next-generation situational awareness tools and high-resolution simulations. Soldiers can see through smoke around corners and receive real-time intelligence overlays that identify threats, friendly forces, and mission objectives directly in their field of view. The system's revolutionary capability lies in its integration of multiple technologies into a single platform. IVAS provides improved mobility and lethality through sensing, mapping, and computing capabilities that enhance mission planning, decision-making, and targeting. Soldiers can rehearse and train in realistic augmented reality scenarios, preparing for specific missions before deployment. Current development focuses on IVAS 1.2, featuring improved form factor, reliability upgrades, and enhanced low-light sensors with distributed counterweight for improved comfort. The Army plans to field approximately 121,500 systems to close combat soldiers, making this technology standard equipment rather than specialized gear. Beyond current capabilities, future iterations may include AI-assisted decision-making, biometric monitoring, and integration with autonomous systems. The technology promises to create soldiers who can process information faster, make better decisions under stress, and coordinate more effectively with both human teammates and autonomous systems. This represents the first step toward truly augmented soldiers who combine human judgment with machine precision and processing power. Quantum computing for defense. The Department of Defense is investing over $100 million in quantum technologies that are set to revolutionize military computing. We're talking about capabilities that could break any encryption, detect hidden submarines, and process battlefield information at speeds that, honestly, make our current supercomputers look like pocket calculators. Quantum computing really represents a paradigm shift in computational technology, one that's going to transform national security and defense operations as we know them. The Pentagon, recognizes three critical applications here: quantum computers for processing vast amounts of data way faster than traditional systems, quantum sensing for detecting enemy submarines and other concealed threats, and quantum communications that offer, unhackable secure channels. The Defense Department's quantum initiatives include the Dakar program, which is focused on testing quantum computing heuristics and exploring near-term applications. Now, DARPA's quantum sensing program, called ROQS, aims to create rugged sensors that can keep their performance even under harsh military conditions. These are already being integrated into space-qualified systems. These sensors, by the way, can detect submarines, nuclear materials, and other hidden threats with a level of precision we've just never seen before. The real military advantage of quantum technology lies in its fundamental properties. Quantum computers could potentially break current encryption methods while, at the same time, providing quantum-resistant security for U.S. communications. The technology enables processing capabilities that, frankly, render traditional computers obsolete when it comes to complex military calculations and simulations. The Pentagon's commitment here also includes establishing a quantum computing center of excellence to strategically scale the technology and build on the momentum that's already underway. This center will focus on quantum computing, integrated photonics, superconducting systems, and trapped ions. As quantum technology matures, it's going to provide the U.S. military with computational advantages that, fundamentally alter the balance of technological superiority in warfare. Artificial intelligence battlefield systems. The Pentagon's generative AI initiative is, creating battlefield systems that can analyze intelligence, recommend targets, and coordinate complex operations way faster than human commanders, fundamentally changing how military decisions are made in combat. Task Force Lima, which is led by the Chief Digital and Artificial Intelligence Office, is synchronizing AI deployment across the Department of Defense to enhance operations in warfighting, business affairs, health, readiness, and even policy. Current applications include intelligent decision support systems and aided target recognition that assist in decision-making, target recognition, and casualty care, all while reducing operator mental load and increasing decision accuracy. Recent deployments really demonstrate AI's battlefield potential. For instance, U.S. Marines in the Pacific have used generative AI chatbots to analyze surveillance data and alert commanders about potential threats. This, honestly, represents the second phase of military AI strategy, moving beyond just computer vision for drone analysis to human-like dialogue systems that can interpret complex intelligence. The technology's revolutionary aspect lies in its speed and processing capability. AI systems can analyze full-motion video that would require human analysts to work 12 hours daily, identifying patterns and threats that humans might miss due to fatigue or information overload. This capability, in turn, expedites decision-making on the battlefield while reducing casualty risk and collateral damage. Looking ahead, future applications include AI systems that not only assess military data, but also recommend actions such as generating target lists. While supporters argue this enhances precision and reduces civilian casualties, the technology, of course, raises important questions about human oversight in life-and-death decisions. The integration of AI into battlefield systems really promises to provide decisive advantages in speed, accuracy, and coordination that no human-only force can match. Advanced Materials Technology. The Department of Defense is developing, revolutionary materials that can stop bullets instantly, heal themselves when damaged, and adapt their properties in real time, creating equipment and vehicles that almost seem to defy the laws of physics. The DoD's Advanced Materials Science and Technology strategy focuses on expediting identification and fielding of materials for defense applications. These efforts span the full materials continuum, from discovery through deployment, targeting engineering problems with multidisciplinary research that establishes fundamental relationships between material structure, properties, and performance. Revolutionary developments include magnetorheological fluids that transform from liquid to impenetrable solid in milliseconds when exposed to magnetic fields. MIT researchers have perfected this technology for potential use in adaptive armor systems that can respond instantly to incoming threats. Meanwhile, Lawrence Livermore National Laboratory has developed fabric from carbon nanotubes that detects and repels chemical and biological weapons. Advanced ceramics like silicon carbide and alumina are being used for armor plates that can withstand high-velocity impacts while remaining lighter than traditional materials. Nanostructured materials exhibit unique properties, including increased strength and conductivity, enabling more efficient sensors, lightweight armor, and advanced energy storage solutions. Smart materials really represent the cutting edge of this technology. Shape memory alloys and piezoelectric materials can change their properties in response to external stimuli, enabling adaptive camouflage, self-healing structures, and energy harvesting capabilities. These materials are just invaluable for defense applications where equipment must adapt to changing conditions. The integration of these advanced materials into military platforms significantly enhances strength and performance while reducing weight and maintenance requirements, providing decisive advantages in mobility, protection, and operational capability. Space-based defense systems. The U.S. military is deploying, constellation networks of satellites equipped with directed energy weapons, hypersonic interceptors, and quantum communication systems that can defend against any threat from orbit while projecting power anywhere on Earth almost instantaneously. Space-based defense really represents the ultimate high ground in military strategy. Current developments include satellite constellations capable of tracking hypersonic weapons, providing early warning, and coordinating defensive responses. The integration of advanced radar systems like the upgraded THAAD and TPY-2 radar demonstrates growing capabilities to detect and track hypersonic missiles from space-based platforms. Looking to the future, space-based systems will incorporate directed energy weapons capable of engaging targets on Earth or in space at light speed. These orbital platforms could provide global coverage with response times measured in seconds rather than minutes or hours. The combination of quantum communication systems ensures these networks remain secure from cyber attacks while coordinating complex defensive and offensive operations. The strategic advantage of space-based systems lies in their global reach and rapid response capability. Unlike ground-based or air-based systems limited by geography and deployment time, space-based platforms provide persistent coverage of any location on Earth. They can simultaneously serve defensive roles by intercepting incoming threats and offensive roles by striking targets globally. Integration with other revolutionary technologies multiplies their effectiveness. Space-based quantum sensors can detect stealth aircraft and submarines, while AI systems process vast amounts of surveillance data in real time. Hypersonic weapons launched from orbit could reach any target on Earth within minutes. These systems really represent the ultimate evolution of military technology, providing capabilities that ensure space superiority translates directly into terrestrial dominance across all domains of warfare. From hypersonic weapons that outrun any defense to AI systems that think faster than human commanders, these 10 technologies aren't just changing how America fights, they're ensuring that future conflicts will be won before enemies even realize they've begun. Each innovation represents years of research, billions in investment, and the collective genius of America's defense industry. As we stand on the brink of a new era in warfare, one thing is certain: the nation that masters these technologies will dominate the battlefields of tomorrow. Thanks for watching Stellar Tech. Subscribe for more incredible insights into the technologies shaping our world. What if I told you that in 2017, something from another star system visited our solar system, and one of Harvard's top scientists believes it might have been sending us a message? Oumuamua, the first confirmed interstellar visitor, has sparked the most controversial debate in modern astronomy. When Joe Rogan sat down with physicist Avi Loeb, the conversation revealed shocking theories that challenge everything we thought we knew about our cosmic neighborhood. Today, we're diving deep into the mystery that has scientists questioning whether we've already encountered alien technology. The discovery that changed everything. October 19, 2017, marked a historic moment that most people completely missed. On that day, astronomers at the Pan-STARRS telescope in Hawaii detected something that shouldn't exist: an object moving through our solar system at impossible speeds, following a trajectory that proved it came from another star system. Named Oumuamua, meaning messenger from afar arriving first in Hawaiian, this mysterious visitor was unlike anything scientists had ever encountered. The object was traveling at 196,000 miles per hour, far too fast to be captured by our sun's gravity. Its hyperbolic trajectory confirmed what seemed impossible. We were witnessing humanity's first confirmed interstellar visitor. What made this discovery truly extraordinary wasn't just its origin but its timing. Astronomers estimate that interstellar objects like Oumuamua pass through our solar system about once per year, but they're typically too faint and fast to detect. Only recently had our telescopes become powerful enough to spot such visitors. The fact that we caught this one suggested either incredible luck or that these objects might be more common than previously thought. Within days of its discovery, Oumuamua would reveal characteristics that would divide the scientific community and spark debates that continue today. An object unlike anything we've seen. The more scientists studied Oumuamua, the stranger it became. This wasn't just another space rock. It was something that defied every category astronomers had for celestial objects. The object's shape was the first major anomaly. Based on how its brightness changed as it tumbled through space, scientists calculated that Oumuamua was extremely elongated, roughly 10 times longer than it was wide. To put this in perspective, imagine a cigar that's 1,300 feet long but only 130 feet wide. No asteroid or comet in our solar system has ever been observed with such an extreme aspect ratio. Even more puzzling was its behavior. As Oumuamua rotated every 7.3 hours, its brightness varied by a factor of 10, the most dramatic brightness variation ever recorded for a natural space object. This suggested either an incredibly unusual shape or surface properties unlike anything in our cosmic neighborhood. The object's reddish color, similar to objects in the outer solar system, indicated it had been wandering through interstellar space for hundreds of millions of years, its surface reddened by cosmic radiation. Yet despite this ancient journey, Oumuamua showed no signs of the dust or gas emissions typical of comets when they approach the sun. The acceleration mystery that baffled scientists. Just when astronomers thought they understood Oumuamua, the object delivered its most shocking surprise. It was accelerating away from the sun in a way that gravity alone couldn't explain. This non-gravitational acceleration was subtle but unmistakable. As Oumuamua sped away from our solar system, it was moving faster than it should have been based purely on gravitational calculations. For comets, this kind of acceleration is normal. Ice vaporizing from their surface creates a rocket-like effect. But Oumuamua showed absolutely no signs of cometary activity. The acceleration was consistent and measurable, ruling out random forces or measurement errors. Something was pushing Oumuamua, but what? Traditional explanations fell short. The object was too small for solar radiation pressure to account for the observed acceleration, and it lacked the outgassing that typically propels comets. This mysterious acceleration became the smoking gun that would fuel the most controversial theory in modern astronomy. If natural explanations couldn't account for Oumuamua's behavior, what could? The answer would come from an unexpected source: Harvard's Department of Astronomy, where one physicist was willing to consider possibilities that others dismissed as impossible. The stage was set for a scientific revolution that would challenge our understanding of our place in the universe. Avi Loeb's revolutionary theory shakes science. When Harvard physicist Avi Loeb appeared on Joe Rogan's podcast, he dropped a bombshell that sent shockwaves through the scientific community. Oumuamua might be artificial technology from an alien civilization. Loeb, former chair of Harvard's astronomy department, wasn't some fringe theorist. He was a respected scientist with hundreds of published papers, who had simply followed the evidence to its logical conclusion. Just like Sherlock Holmes, I follow the evidence, trying to find the solution. The physicist's theory centered on one key insight. Oumuamua's unusual properties perfectly matched what engineers would design for an interstellar light sail. Its extreme thinness would minimize damage from interstellar dust, while its flat geometry would maximize surface area for solar radiation pressure. Exactly what would propel a light sail through space? Loeb's calculations showed that solar radiation pressure could indeed account for Oumuamua's mysterious acceleration, but only if the object was incredibly thin, like a sheet of paper tumbling through space. This wasn't just speculation, it was based on rigorous physics and observations that other natural explanations couldn't adequately address. The scientific establishment's reaction was swift and harsh, but Loeb stood firm in his assessment. The light sail theory that changes everything. The concept that Oumuamua could be an alien light sail isn't science fiction, it's cutting-edge physics that we're already developing here on Earth. Light sails work on a simple principle. Photons from stars carry momentum that can push extremely thin reflective surfaces. Just as wind pushes a ship's sail, starlight can propel a spacecraft equipped with a large, lightweight sail. The technology is so promising that organizations like Breakthrough Starshot are developing light sail probes to reach nearby star systems. Oumuamua's behavior perfectly matched what scientists would expect from a light sail. Its acceleration was consistent with solar radiation pressure acting on a thin, flat object. The lack of outgassing made sense because artificial objects wouldn't contain volatile materials that vaporize near the sun. Even its tumbling motion resembled how a damaged or derelict light sail might behave after millions of years in space. Maybe it was just alien craft technology that unintentionally lost itself, like space junk. Loeb suggested, making the theory seem less threatening and more plausible. The search for alien signals begins. The possibility that Oumuamua might be artificial technology triggered the most intensive search for alien signals in modern history. Breakthrough. Listen, the world's most comprehensive SETI program immediately turned the massive Green Bank telescope toward Oumuamua. If the object was indeed artificial, it might be transmitting signals, either intentionally or as electromagnetic leakage from its systems. The search was unprecedented in its scope and sensitivity. Over multiple observation sessions, the telescope scanned billions of radio frequencies, recording a staggering 90 terabytes of data, enough to fill 23 high-end computers. The observations covered different phases of Oumuamua's rotation, ensuring that any potential signals from different parts of the object would be detected. The sensitivity was remarkable. At Oumuamua's distance, the telescope could have detected a signal as weak as a cell phone transmission. If alien technology was aboard this mysterious visitor, we would have heard it. The results were both disappointing and reassuring. No artificial signals were detected from Oumuamua. The object remained silent as it tumbled through space, offering no direct evidence of alien technology. However, the absence of signals didn't disprove the artificial hypothesis. A derelict piece of technology wouldn't necessarily be transmitting.
Why natural explanations fall short.
The scientific community's resistance to Loeb's alien hypothesis led to, well, increasingly creative attempts to explain Oumuamua through natural processes, but each explanation just seemed to create new problems. One theory suggested that Oumuamua was a hydrogen iceberg, basically a chunk of solid hydrogen that would sublimate near the sun, causing the observed acceleration. But, solid hydrogen couldn't actually survive the millions of years needed for interstellar travel, and the object didn't show any of the expected hydrogen emissions. Another proposal claimed Oumuamua was a fragment of a disrupted comet, but this idea couldn't account for its extreme elongation or the lack of any cometary activity. Some scientists even suggested it was a dust bunny, meaning a loosely bound collection of particles, but an object like that would have been torn apart by tidal forces during its close approach to the sun. The most recent theory proposed that Oumuamua was made of nitrogen ice, kind of like Pluto's surface. While this could maybe explain some of the observations, it would require the object to have originated from a Pluto-like world in another star system, which is, honestly, itself a pretty extraordinary claim. So, each natural explanation required increasingly exotic conditions or materials, leading some scientists to start questioning whether the artificial hypothesis might actually be the simpler explanation. The implications of alien technology. If Oumuamua truly represents alien technology, the implications for humanity are, honestly, staggering, and fundamentally change our understanding of our place in the universe. The object's properties suggest it wasn't sent to spy on Earth or, make contact. Its trajectory showed no signs of course corrections toward our planet, and it was already leaving the solar system when we discovered it. This supports Loeb's theory that we encountered cosmic debris, the equivalent of finding a piece of alien trash just floating through space. Strangely enough, this scenario might actually be more significant than active alien contact. It suggests that technological civilizations are common enough that their artifacts regularly drift through the galaxy. If Oumuamua is artificial, it implies that advanced civilizations have been building interstellar technology for, well, millions of years, leaving a trail of debris in their wake. The discovery would also validate humanity's own technological trajectory. We're developing light sail technology for interstellar exploration, which suggests that this approach represents a natural evolutionary step for spacefaring civilizations. Oumuamua might be showing us our own future, a time when human-built light sails will traverse the galaxy, potentially becoming mysterious visitors to other star systems.
The race against time and distance.
One of the most frustrating aspects of the Oumuamua mystery was just how quickly the opportunity to study it disappeared, highlighting the challenges of investigating interstellar visitors. By the time scientists realized Oumuamua's true significance, it was already racing away from the sun at, honestly, incredible speed. The object was moving so fast that no existing spacecraft could catch up to it for a closer look. Even our most powerful rockets would have taken decades to reach Oumuamua, and by then it would be way too far away to study effectively. This time, pressure forced astronomers to make critical observations with ground-based telescopes while the object was still detectable. Every day that passed meant Oumuamua was getting fainter and harder to observe. The window for detailed study lasted only a few months before the object became too distant for meaningful analysis. The experience taught scientists some valuable lessons about preparing for future interstellar visitors. New detection systems are being developed to spot such objects earlier, giving researchers more time to study them. Space agencies are also considering rapid response missions that could be launched quickly to intercept future visitors before they escape our solar system.
What Oumuamua means for the future.
Oumuamua's brief visit has, without a doubt, fundamentally changed how we think about interstellar space and our search for extraterrestrial intelligence, regardless of whether it was natural or artificial. The object proved that interstellar visitors are detectable with current technology, opening a whole new field of astronomy. Scientists now know what to look for and have developed protocols for studying future visitors more effectively. The recent discovery of additional interstellar objects, including Comet 2I Borisov and the newly detected 3I Atlas, shows that Oumuamua wasn't a unique event. If Oumuamua was indeed artificial, it suggests that the galaxy might be filled with technological artifacts from ancient civilizations. This archaeology of the galaxy approach to SETI represents a new way of searching for evidence of alien intelligence, not through radio signals, but through physical artifacts drifting through space. The controversy surrounding Oumuamua has also highlighted the importance of keeping an open mind in science. Loeb's willingness to consider unconventional explanations, despite professional criticism, really demonstrates the value of following evidence wherever it leads. As we continue to develop our own interstellar technology, Oumuamua serves as a reminder that we might not be alone in this cosmic endeavor. From its mysterious acceleration to its impossible shape, Oumuamua challenged everything we thought we knew about our cosmic neighborhood. Whether it was a natural phenomenon or humanity's first encounter with alien technology, this interstellar visitor opened our eyes to possibilities we never imagined. As Joe Rogan and Avi Loeb showed us, sometimes the most extraordinary explanations deserve serious consideration. The truth about Oumuamua may remain a mystery, but its impact on science and our understanding of the universe will last forever. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic mysteries. The moon, long thought to be a silent, inactive rock, is now revealing secrets that could change everything we know about our closest celestial neighbor. Renowned physicist Michio Kaku has issued a warning after NASA detected a mysterious seismic signal deep within the moon's core. This discovery challenges decades of assumptions and hints at dynamic processes that might even impact Earth over geological timescales. Today, we explore what this seismic activity means for lunar science, future missions, and our understanding of planetary evolution.
The moon's hidden activity revealed.
For decades, scientists believed the moon was geologically dead, its core solidifying and cooling quietly like a dying ember in space. But recent data from NASA's lunar sensors have detected unexpected seismic pulses emanating from deep within the moon's interior, challenging everything we thought we knew about our celestial companion. These signals suggest the moon's core is not just passively cooling, but undergoing significant changes that could reshape our understanding of lunar evolution. Physicist Michio Kaku has highlighted these findings in recent lectures, warning that the moon's internal activity could have long-term effects on its structure and even Earth's environment over geological timescales. This seismic activity challenges the traditional view of the moon as a static, inert body that finished its geological story billions of years ago. The discovery represents a paradigm shift in lunar science, forcing researchers to reconsider fundamental assumptions about how small planetary bodies evolve and die in our solar system.
Inside the moon's dynamic core structure.
The moon's internal structure resembles a miniature version of Earth's, with a solid inner core surrounded by a partially molten outer core that scientists are now discovering remains more active than previously thought. New analyses estimate the inner core's radius at approximately 240 kilometers, primarily composed of iron and nickel, enveloped by a fluid outer core extending roughly 350 kilometers from the moon's center. Geological evidence from lunar rocks brought back by Apollo missions shows the moon once possessed a magnetic field generated by its core, similar to Earth's protective magnetosphere. This ancient magnetic field, which existed billions of years ago, gradually faded as the core cooled and solidified. However, recent seismic data suggests the core might still be active in subtle but measurable ways. The core's structure includes a partial melt layer at the base of the lunar mantle, approximately 150 kilometers thick, which sits above the liquid outer core. This complex internal architecture indicates that the moon's interior remains more dynamic than the simple cooling model previously accepted by planetary scientists. Apollo's legacy and modern seismic discoveries. NASA's Apollo missions first placed seismometers on the moon between 1969 and 1977, with the Apollo 11 passive seismic experiment marking humanity's first attempt to listen to another world's internal activity. These instruments detected moonquakes and revealed some internal activity, recording about 100 to 200 meteorite impacts during their operational lifetime and detecting several categories of seismic events. However, the resolution of those 1970s instruments was limited by the technology available at the time. The Apollo seismometers operated until September 1977, providing valuable but incomplete data about lunar seismic activity. Now, with advanced sensors and modern analysis techniques, scientists are uncovering new categories of seismic events that were previously undetectable. These include deep moonquakes caused by tidal forces with Earth, shallow quakes with tectonic origins, and thermal quakes caused by extreme temperature fluctuations between lunar day and night. The new data suggests the moon's interior is more dynamic than once thought, with ongoing processes that continue to shape its internal structure even today.
The shrinking moon theory and tectonic activity.
One of the most intriguing hypotheses emerging from recent research is that the moon is slowly shrinking as its core continues to cool and solidify over geological time. This gradual contraction causes stress in the brittle lunar crust, leading to the formation of tectonic ridges, fault lines, and surface scarps that are surprisingly young in geological terms. Recent studies have identified hundreds of previously unknown ridges on the moon's surface, some of which may have formed as recently as 200 million years ago, a blink of an eye in geological terms. Using advanced mapping techniques and crater counting methods, scientists determined that these small ridges are younger than other features in their surroundings, meaning the moon's crust is still shifting and evolving today. This slow contraction and associated seismic activity could explain the mysterious seismic pulses detected recently, suggesting the moon is still adjusting internally as it continues its billion-year cooling process. The discovery challenges the long-standing belief that the moon became geologically dormant billions of years ago, and suggests that internal forces are still shaping its surface in measurable ways.
Earth-Moon gravitational dance and climate implications.
The implications of the moon's internal activity extend far beyond lunar science, potentially affecting Earth's long-term climate stability and orbital dynamics. The moon's gravitational influence stabilizes Earth's axial tilt at 23.5 degrees, which regulates our seasons and prevents chaotic climate swings that would make complex life difficult to sustain. Changes in the moon's mass distribution due to core activity and internal restructuring could subtly affect this crucial gravitational relationship over timescales of millions of years. While these effects are not immediate or catastrophic, they could influence Earth's climate cycles, tidal patterns, and even the Milankovitch cycles that govern ice ages over geological epochs. Michio Kaku has emphasized that the moon acts like a cosmic stabilizer, preventing Earth from wobbling chaotically like other planets of similar size. This stability has allowed for the slow, steady development of ecosystems and eventually human civilization. The moon's gravitational pull creates not just ocean tides, but also slight bulges in Earth's crust, generating heat through friction that contributes to our planet's internal warmth and geologic activity.
Next-generation lunar seismic monitoring.
NASA is preparing to deploy revolutionary new seismic instruments on the moon as part of upcoming Artemis missions, representing a quantum leap forward in our ability to monitor lunar internal activity. The Farside Seismic Suite, scheduled to land in Schrödinger Basin around 2026, will be the first seismic station placed on the moon's far side since the Apollo era. These next-generation seismometers will be approximately 30 times more sensitive than Apollo-era equipment, capable of detecting ground motions smaller than a single hydrogen atom. The Very Broadband Seismometer, originally designed for Mars InSight mission, represents the most sensitive seismometer ever built for space exploration. Additionally, the Lunar Environment Monitoring Station will establish a long-duration seismic station near the South Pole, where NASA's Artemis missions plan to build a permanent human presence. Unlike Apollo instruments that operated for limited periods, these new systems are designed to continuously monitor lunar seismic activity for months or even years, providing unprecedented insights into the moon's internal dynamics.
AI revolutionizes Apollo-era data analysis.
Artificial intelligence is playing, a crucial role in revolutionizing our understanding of lunar seismic activity by analyzing decades-old Apollo data with unprecedented precision. It's like machine learning algorithms are detecting patterns and anomalies in the original seismic recordings that human analysts missed or dismissed as noise during the 1970s analysis. These sophisticated AI systems can distinguish between genuine lunar activity and instrument artifacts with remarkable accuracy, flagging seismic events that didn't fit expected patterns and were often filtered out as measurement errors decades ago. NASA scientists describe this process as revolutionary, comparing it to having a conversation with someone for 50 years and suddenly realizing you've been missing half of what they've been saying. The AI analysis has revealed entire categories of seismic events occurring beneath the lunar surface that were completely missed by previous analysis techniques. These aren't just minor tremors but signatures of complex processes happening in the moon's core that provide new insights into its internal structure and ongoing geological activity. This technological breakthrough is helping scientists reconstruct a completely new picture of the moon's internal dynamics and the seismic pulse that has drawn Michio Kaku's attention.
Lunar exploration safety and future mission planning.
So, the discovery of ongoing seismic activity on the moon, well, it really raises some critical safety considerations for future lunar exploration and colonization efforts. Human missions and those mining operations planned near the lunar South Pole, they've got to carefully consider the risks posed by tectonic activity and potential moonquakes that could damage habitats or endanger astronauts. Understanding fault zones and stress patterns is just essential if we want to ensure the safety and stability of lunar habitats and infrastructure. Unlike Earth, the moon's crust doesn't have water circulation to heal cracks naturally, so once we fracture its brittle surface through mining or construction, those fractures could stick around and potentially trigger even larger seismic events. NASA's upcoming seismic networks will be absolutely vital for mapping these geological hazards and guiding mission planning for the Artemis program. The lunar regolith, which is that layer of loose material covering the moon's surface, actually sits atop a pretty complex network of faults and stress zones that could be disturbed by human activity. Future lunar bases are going to be completely dependent on their structural integrity, making seismic monitoring crucial for astronaut safety, and a habitat breach caused by unexpected seismic activity could be catastrophic, exposing crew members to the vacuum of space with very little warning or opportunity for evacuation.
A rare cosmic window for scientific discovery.
Michio Kaku emphasizes that humanity exists in a rare cosmic window, a fleeting moment in astronomical time when the moon's internal activity is still detectable before it eventually ceases forever. In another billion years or so, the moon's core may freeze solid completely, ending the geological processes we can observe today. This unique opportunity allows scientists to study planetary evolution processes that happen over billions of years, providing insights that, honestly, can't be obtained any other way. The moon is pretty much giving us a live demonstration of how small planetary bodies evolve and eventually become geologically inactive, serving as a sort of natural laboratory for understanding planetary death. Insights gained from studying the moon's core activity can inform our understanding of other rocky bodies in the solar system and beyond, including potentially habitable exoplanets. By watching the moon transition from a molten core to a solid one, scientists gain crucial insights into how different-sized worlds evolve, whether they can maintain protective magnetic fields, and their potential for supporting life. Kaku explains that we're incredibly fortunate to exist at exactly the right moment to witness the final chapters of the moon's geological story.
The moon as a key to planetary evolution.
The moon's seismic signals represent far more than just scientific curiosities. They're actually fundamental keys to understanding planetary life cycles throughout the universe. As the moon's core continues to cool and solidify, it offers researchers an unprecedented live demonstration of how small planetary bodies evolve and eventually die, providing crucial data for planetary science models. This knowledge is particularly vital as humanity prepares to return to the moon and establish a permanent presence there. Understanding the moon's internal processes helps scientists identify potentially habitable exoplanets and predict how their geological evolution might affect their ability to support life over billions of years. The moon serves as an intermediate step in planetary development, larger than asteroids but smaller than Earth-like planets, giving us really important insights into how different-sized worlds evolve. By studying how the moon's core solidifies and loses its magnetic field, scientists can develop models that predict how long smaller rocky exoplanets might maintain their protective magnetic shields. Michio Kaku's warning reminds us that the moon still holds secrets that could totally reshape our understanding of planetary science, Earth's future, and our place in the cosmic neighborhood. The moon is no longer the silent, dead rock we once thought it was. Thanks to new seismic discoveries and Michio Kaku's warnings, we now know it's a dynamic world with an active interior that could even influence Earth itself. As we prepare to return and explore further, understanding these internal processes is more important than ever before. Stay tuned for more updates on lunar science and the future of space exploration. Thanks for watching Stellar Tech, and don't forget to subscribe for more cosmic insights.